So we're looking at the slope-intercept form, y equals mx plus b. The m here represents rate of change. Now in the last lesson that we did, we learned how to find rate of change in tables and in graphs. The m here in this equation represents the rate of change. And if you remember what we learned, we know that the rate of change is the change in y over the change in x. Again, you can find this in a table or in a graph. So, yeah, write that down. And then the b here, I'm going to use green for the b. The b here represents the y-intercept. I'm only going to write y-int. But you should have that letter or that word y-intercept from last night's notes, right? Y-intercept. And what that means is that's the point at which the line crosses the y-axis. Now you notice I have a couple graphs here. These are actually from today's assignment. Now if you notice in this graph, the y-intercept is the point where the line crosses the y-axis. So if we're looking at this graph, this is the y-intercept right here. Does everybody see where I put my dot, my point? That's the y-intercept. So the y-intercept here would be, if we're going to write it as an ordered pair, it would be, oops, not -0. So if I was going to write it as an ordered pair, it would be 0, because the x here is 0, the y value is -1. But in slope-intercept form, like we're seeing right now, if you look at the equation below here, I have an example for you. This here is the y-intercept, right? And it's a positive 1. You're going to see what that looks like on the graph here in just a second. So I showed you the rate of change m, the y-intercept, and it's represented by a b here because the y-intercept is the point where the line crosses the y-axis, and it's not the y value itself, right? The y value is something entirely different. If you watch the video, it also talked about this x here being the input, and then it talked about this y over here as the output. We're going to see what all that means. Now moving on. So in the equation this is number 1 from today's assignment, you'll see our linear equation here is y equals -1/2 x plus 1. When I'm looking at these, the easiest thing for me to identify is the y-intercept. So we have a y-intercept that's 1, or what this means for our graph would be, that point would be 0, 1. Our x value would be 0, our y value would be 1. So we're going to look at these graphs and we're going to try to figure out which one of these shows a y-intercept of positive 1, because if you see it's a plus 1. So out of A, B, C, or D, which one or which ones show a y-intercept of a positive 1? B, right? So I'm going to mark B for you. Oops. So look, does everyone see the y-intercept of 1 here? Right? The line crosses the y-axis at 1. I'll zoom out. We'll look at C. Does C have a y-intercept of 1? No. Is that not a y-intercept of 1 there? Yes. Yes, right? Let's look at D. Yes. Does D have a y-intercept of 1? Yes. So those three choices are in the game right now. We're trying to find out which one of these graphs represents the equation -1/2 x plus 1. So far there's 3 choices that we've identified that can be possible answers. Next, we're going to look for the rate of change. Now this rate of change here, -1/2, that's our change in y over our change in x. So what this means is our change in y is a -1, our change in x is a -2.
Why did you put -1 there?
Well, because it's a -1/2.
See?
You see negative 1/2 right there? Right? It's a negative 1/2. One of these has to be negative. The 1 or the 2. They both can't be negative because if you divide a negative by a negative, you get a what?
Positive.
Positive, right? So one of these has to be negative. They both can't be negative. We're going to see what that looks like on the graph. So when we talk about our rate of change being negative, right? When we have a negative y, does y go up or down, left or right? It goes up and down, which means if I start at my y-intercept and my y is changing by negative 1, it's going to go down. So we'll go down 1. And how much was the x changing by?
1/2.
It's not changing by 1/2.
Negative 1.
Remember, it's changing y over the change in x. So how much was x changing by here?
Negative 1/2. No, 2.
X is changing by 2. Y is changing by negative 1. X is changing by 2. So if we're going back here, the y, we went down 1 because it's a negative 1. How many are we going to go over? First of all, are we going left or right?
Right.
What was the change in x?
2.
It was a positive 2, so are we going left or right?
Right.
So let's see what that would look like. 1, 2. That would be the next point in our line. And then we're going to continue to follow that pattern. We'll go down 1 over 2, down 1 over 2. Does this graph represent that equation?
Yes.
Does it? Does that line follow along these points? No, right? So that one doesn't fit. Yes? Question?
How do you know if the denominator or numerator is negative?
Well, as long as one of them is negative, that's the important part, right? So I'll show you what I mean. So his question was, how do you know if the numerator or the denominator is negative, right? As long as only one of them is negative, then we're fine. But again, if both of them are negative, then a negative divided by a negative equals a what? A positive. So only one of them could be negative. I'm going to show you using another color. Let's say, for instance, that the 1 was positive and that the 2 was negative, right? So starting out here, if our 1 is positive, which direction are we going? Up or down? We're going up. And then if our 2 is negative, which way are we going? To the right or to the left? To the left. 1, 2 spaces. I go up 1 over 2. You see how it's all part of that same line? Right? So it doesn't matter if the numerator or the denominator is negative. For me, I would tell you as a rule of thumb to just make the numerator negative because it's easier, right? To have like a rule. So we looked at that one. A was not the answer. We're going to look at B now. We said the rate of change was a negative change in y by 1 and then a change in x by 2. So let's try it here. Am I going up or down?
Down.
Down. We're going down by 1 because it was a negative 1. How much did the x change by? 2. So we're going to go over 2. Down 1, over 2. Down 1, over 2. Is this our equation here?
No.
Does it match with the graph?
No.
No, right? Let's try C. Now, so we're left with C and D at this point. And they're pretty close, and they try to trick you here. Because C and D are like backwards, right? And you're going to see what I mean by this, right? C and D have opposite rates of change. One is 1/2, and the other one's 2 over 1, right? Because if you look, they're both negative rate of change because the line goes down and to the right. So they're both negative. Now, on this one, we said our change in y, or our vertical change, we were going down how many?
2, 1.
Our change in y was negative 1, right?
Yeah.
So we're going down 1 over 2. Down 1 over 2. Down 1 over 2. Is this our graph?
No.
No, but look what they did. What they did was they went down 2 over 1. I'm going to show you how they try to trick you. Look, they went down 1, 2. They went over 1. Look at that point there. They went down 2. They went over 1. Look at that point there. They went down 2 over 1. They tried to trick you. The rate of change of the line in this graph is negative 2 over 1. You see how that's the opposite of the 1/2?
Yeah.
Right? So there's always going to be an answer choice that's the opposite. And now we're going to look at our winner chicken dinner. Right?
To get the answer, you just have to go down 1 and then switch
I'm going to summarize everything that we just did. So you're going to see exactly what the trick is, more or less. So remember, we said our rate of change was negative 1 over 2. So this is our change in y, negative 1. 2, our change in x. So our negative 1, are we going up or down? Down. And then our 2, are we going left or right? We're going to the right 2 spaces. Is that on our line?
Yes.
Let's go down 1 over 2 spaces. Down 1 over 2 spaces. You see how that all fits on the line?
Yes.
Right? So let's review everything that we just did. So first of all, we reviewed slope-intercept form y equals mx plus b, where m represents the rate of change. By now, we've had practice with finding the rate of change in tables and graphs. It means that it's the change in y over the change in x. Then, we also learned that the variable b here is the y-intercept. And we said that the y-intercept was the point where the line crosses the y-axis. For this particular equation, y equals negative 1/2 x plus 1. We realize that the negative 1/2 is the rate of change here. This means that y is changing by negative 1, which means it's going down by 1, and the x is changing by 2, which means it goes to the right 1. And then we also know that here, this is our y-intercept, 1, which means our line is going to cross the y-axis at 1. When you're doing these problems, the first thing you want to look for is the y-intercept. It's the easiest thing to identify. The rate of change, or the m, involves a little bit of math. But the y-intercept, it doesn't take, you don't even have to be what you think of as a good math student, right? You need to be able to look and say, hey, where does that line cross the y-axis? You're going to look for that number, that's the y-intercept. You can usually get rid of at least one answer choice when you're able to identify the y-intercept. So we got rid of
A.
Then we had B, C, and D left. From B, C, and D, then we had to look to see which one had a rate of change of negative 1/2. And the way that you do it is just by counting. You don't have to do any math, right? But I'm going to show you what the math would look like if you want to do the math, because the counting part doesn't make sense to you, right? Somebody shake their head no, right? So, what would this point be right here? My y-intercept. What would that be as an ordered pair, x, y? This point right here on my graph, what is that?
Where?
This little black point that I made.
0, 1.
Right? The x and y, right? What would that be? 0, 1. And then we need to find one more point. What would this point right here be that I just made with red?
2, 0.
That point would be 2, 0. And then we're going to make a table. Remember how I taught you how to do this? No!
Taking attendance at this time, please do so before the end of the day. And then I'll run my report and let some of you know who have been taking attendance. Please take your attendance at this time. Thank you.
You just ruined my video. All right. So now we're going to find, using math, what the rate of change is. How much does it change by from 1 to 0 here?
0.
Let's be very...
Negative 1.
Minus 1, right? What does it change by from here to here?
2.
2. So our change in y was a negative 1. Our change in x was 2. So you have two ways of doing this to find the rate of change. You can look at the line and you can trace the line. Here, I pick 2 points on my line, and then I ask myself, how much is the y changing by? How much is the x changing by? How much is the y changing by? Negative 1. How much is the x changing by? That's one way of doing it. Or you can put the numbers in a table like we did here. I gave you 2 ways of doing it. This is number 1 on today's assignment. And then this applies pretty much to every problem that you're doing in this assignment.